Hi, welcome to 10.4, Part 2. We're going to be, really all we're doing is dividing radical expressions today. So our objectives are going to be 1 and 2. Use the quotient rule to simplify radical expressions, and use the quotient rule to divide radical expressions. So let's go to page, and on page 2, let me zoom in here. We left off for example 4 was the last thing that the first thing, sorry, checkpoint 3 was the last thing we did, so that means we're starting up on example 4. And we're going to use the quotient rule to simplify these things. And the quotient rule says that if we're taking the cube root or the square root or any other root of a fraction, it's the same as taking the whatever root, square root or cube root, of the top of the fraction over the square root or cube root of the bottom of the fraction. So you can do them separately. So let's look at A. We have, if we split them up and do them separately, we have the cube root of 16 over the cube root of 27. Well, 16, our perfect cubes are 8 and then 27. So 8 goes into 16 twice, so we're going to have to break up the top into the cube root of 8 times the cube root of 2. And the bottom, the cube root of 27, we know is just 3. And so the cube root of 8 is 2, so I got 2 times the cube root of 2 over 3. And that's our answer. On B, if we split it up into the top and bottom, we got the square root now of x squared over the square root of 25y to the 6th. We can do the square root of x squared. You divide it by 2, the power by 2, you get 1, so it's just going to be an x on top. On bottom, square root of 25 is 5, and square root of y to the 6th is y to the 3rd, so 5y to the 3rd. And that's our answer. Let's do C, a fourth root. We've got the fourth root of the top, so the fourth root of 7y to the 5th divided by the fourth root of the bottom, which is x to the 12th. Okay, the top, we can't take the fourth root of 7, and there's no way we can simplify that, so we're just going to have a fourth root of 7 in our answer. But y to the 5th we can split up into y to the 4th times y. And so we're going to have the fourth root of, and I'm going to put the y to the 4th first, because that's the only thing we're going to be able to take the fourth root of, times the fourth root of, I'm just going to leave the 7 and the y under 1, because that's what's going to end up with it anyways. And the fourth root of x to the 12th, we can take 12 and divide by 4. It's 3 times, so that's just going to be x cubed. And on the top, fourth root of y to the 4th is just going to be y. So we got y, fourth root of 7y over x cubed. That's the answer for part C. Go ahead, pause here, try the checkpoint on the next page. When you're done, I'll give you the answers. Okay, checkpoint 4, let me zoom in again here. 4a is 2 times the cube root of 3 over 5. B is 3x square root of x over y to the 5th. And C is 2y squared.
Cameron Bleet, please report to the office. Cameron Bleet, report
Sorry about
to
that.
the office.
Cube root of y over x to the 4th. Okay, those are your checkpoints. Let's look at example 5 now, which is the quotient rule 2. Oops, got to move it up. Excuse my mark there. It's the quotient rule 2, and except for it's going in reverse. The quotient rule also says if I have 2 radicals on each top and bottom of a fraction, in the numerator and denominator, then I can write it as one big one and then do division first. So I can rewrite this as one big square root of 48 x cubed over 6x. And then I can divide my 48 by 6, and I can divide my x cubed by x. So 48 divided by 6 is 8, so I'd get the square root of 8. And x cubed divided by x, really that's an x to the first power. I would subtract the exponents, that would be x squared. So 8x squared, and then I can now take the square root of that. Well, I know 8 breaks down into 4, square root of 4 times the square root of 2, and square root of x squared, I'm not going to break down at all because it's a perfect square. Alright, so I can take the square root of 4, that's 2, take the square root of x squared, that is x, and I got a square root of 2. And that's A. Let's look at B. We got 45xy over 2 times the square root of 5. Sorry, the square root of 45xy over 2 times the square root of 5. I can write a big square root for the things under the square root, but the 2 I'm going to have to put out front. And if the 2 is on bottom, it's the same as a 1/2 out front times the big square root, which would be 45xy over 5. Now if I divide the 45 by 5, I just get 9xy, square root of 9xy times a half. Square root of 9 is 3. So I can get take that out of the square root, but the x and the y are going to stay in. So I would have 1/2 times 3 square root of xy. And a half times 3, I can write this as 2 ways.
Talon Robinson, please report to the office. Talon Robinson, report to the office.
Okay, sorry about that again. I can write it as 3 square root of xy over 2. Or I can just take the 3 and multiply by 2 and get 3/2 square root of xy. It doesn't matter how you write that, either way. Let's look at C. We're going to rewrite them as one big cube root. So I've got cube root of 16x to the 5th y squared over 2x y to the -1. And if I do the division, I'm going to have the cube root of 8, 16 divided by 2 is 8, x to the 5th divided by x, we subtract, remember x has a 1 on it, so it'd be x to the 4th, and y squared divided by y to the -1, we would subtract, and we're going to subtract a -1, so that's really adding, so we're going to have y 2 minus a -1 is really y to the 3rd. Alright, the cube root of 8, we can take the cube root of 8, that's 2, but x to the 4th, I'm going to have to split up. So I could split up to everything, really. I got the cube root of 8 times the cube root of, we're going to have an x to the 3rd times the cube root of x times the cube root of y to the 3rd. And now I can take the cube root of 8, that's 2. The cube root of x to the 3rd is x. I got a cube root of x, and the cube root of y to the 3rd is just y. If I put everything that doesn't have a cube root on it in front, I got 2xy and the cube root of x left underneath the radical. That's all for C. Pause here, try your checkpoints. When you come back, I'll give you the answers. Alright, checkpoint 5. You should get 2x squared square root of 5. B should be 5 over the square root of xy over 2, or 5/2 square root of xy, either one. And c is 2x squared y. That's all for this section. I will see you tomorrow.